Welcome everyone to this video. We'll be doing question 7 uh, in paper 1, which came in JEE Advance 2019. So in this question we have a circuit, as you might be able to see. In this circuit we are supposed to find what is the configuration of the circuit when switch S1 is closed. So when S1 is closed, all the capacitors will be shorted and only resistors and the battery would be operating. So this is the first option which is asked. At time t is equal to 0, the key S1 is closed. The instantaneous current in the closed circuit will be how much? So this is rather easy. We can directly say that the instantaneous current would be the voltage 5 divided by the complete resistance 200 ohm. So that is 5 upon 200, which would be 2.5 into 10 to the power minus 2 amperes, or some 25 milliamperes. So option A we are getting right. Option B is if S1 is kept closed for a long time so that the capacitors are fully charged, the voltage across the capacitor C1 will be. Now when the resistance in the circuit becomes uh, of no consequence, when the capacitor becomes fully charged, we can simply say the voltage, which is 5 volt, will be distributed across all the capacitors C1, C3 and C4. So we just need to find what is the equivalent capacitance of the circuit. So the equivalent capacitance on the circuit, that is what we have to do. So equivalent capacitance of C3 and C4, that would be 40 microfarad. Equivalent capacitance of 40 and 10, that we can find. This is 80 microfarad. So the charge which went to the circuit is some 40 microcoulombs. Corresponding voltage across C1 capacitance is Q by C, that is 40 divided by the capacitance itself, which is 10. So this is 4 volts. So option B as well is correct. Now we have option C. In option C we have closed S1. Now when S1 is kept closed for a long time such that the capacitors are fully charged. Now key S2 is closed. At this time the instantaneous current across 30 ohm resistor between P and Q will be. So between P and Q there are two 30 ohm resistors, this resistor as well and this resistor as well. Both of them we can say. So this option is uh, rather ambiguous one. Instead, let us do option D. If S1 key is kept closed for a long time, such that capacitors are fully charged, the voltage difference between points P and Q. Again, the same case when the capacitors are fully charged. In that case, the voltage difference across points P and Q would be the same as that across C1, because there is no consequence of the 70 ohm resistor, so the voltage difference has to be 4 volt. So again option D becomes incorrect. Uh, Still, we want to evaluate what would be happening in the circuit when we close S2. So when S2 is closed and S1 is also closed, so instantaneously the capacitor would behave like a battery. At that particular instant, we'll have to think in that way. That the capacitor behaves like a battery. So these batteries C3 and C4, they will also become battery. C1 will also become a battery of 4 volt. C3, what would be the potential difference across C3? Um, so potential difference across C3 would be charge in C3, that is 40 divided by potential divided by the capacitance, that is 80. So it will have half volt of potential difference. Similarly, C4 will also have some half volt of potential difference. And these potential difference will basically add up. So we can say they will contribute to 1 volt of potential difference. So the battery, which plate now will have a positive potential. So this plate will have a positive potential and this plate will have a negative potential. Similarly here as well, this plate will have a positive potential and this plate will have a negative potential. So they will reduce the potential difference of this 5 volt battery by 1 volt. So effectively this battery would become that of a 1 volt battery, and this battery is already will become 5 minus 1, that is 4 volts. So just we want to write the equation. So we have a 4 volt battery which is connected to a resistor of 70 ohms. We have another battery of 10 volts which is connected to, which is shorted to through a capacitor. We have a battery of 5 minus 1 which we calculated 4 volts, and this whole resistance is some 130 ohm. So there now what we'll do is that we'll write the current flowing in the circuit. So that is rather easy to evaluate because there is no resistance. Is there resistance? Yes, there is resistance. 30 ohm resistance is there. So this is 30 ohm resistance. So after evaluating all of this, we will be able to find what is the current through this particular resistance. So thank you for joining and have a good day.